Bismillahirrahmanirrahim. Welcome to section 3.4, the process communication or IPC. So process within a system can be independent or cooperating. For independent means that process does not share data with any other processes. Okay, while for cooperating process, it can affect or be affected by other processes. So clearly, any process that shares data, okay, with other processes is a cooperating process. Okay, so there are several reasons why we need to cooperate among processes. Okay, number one, information sharing. Okay, since several applications may be interested in the same piece of information, such as copying and pasting, we must provide an environment to allow concurrent access to such information. Number two, due to computation speed up, okay, if we want a particular task to run faster, so we must break it into subtasks. Okay, each of which will be executing in parallel with the others. Okay, so speed up can be achieved only if the computer has multiple processing core. Okay? That is why quad core is more faster than dual core. Okay? If the other reason because modularity. Okay, if we want to construct um, we may want to construct the system in a modular fashion. So where we can divide the system function into separate processes or thread. Okay. So thread we will learn in next chapter. Okay, for the last reason is convenience. So for convenience, actually is referred to the model in IPC. For this is referring to shared memory, where shared memory allows maximum speed and convenience for of communications, since it can be done at memory transfer speeds when it takes place within a computer. Okay. So we will discuss about shared memory right after this. Okay. So cooperating process need inter-process communication or known as IPC. So we have two models of IPC. Okay. We have shared memory and message passing. So we look at the difference between these two. Okay. For shared memory, as its name implies, okay, we have okay, here we have a region of memory that is shared by the cooperating process. So, for example, process A and between process A and process B. Okay, so shared memory will be is established, okay, between these two processes. So processes can then exchange information by reading and writing the data into the shared region. Okay. Okay. While for message passing, okay, so communication takes place by means of exchange here, okay, between the cooperating processes. Okay. So that is the difference between shared memory and message passing. Okay. For message passing, okay, it is useful for exchanging smaller amount of data because no conflicts need to be avoided. Okay. And it is actually also easier to implement message passing in a distributed system than shared memory. Okay. Okay. For shared memory, okay, the advantage of shared memory compared to message passing. Okay. Shared memory can be faster than message passing. Okay, since message passing are typically implemented using system call, okay, and thus require the more time consuming task of kernel intervention. Okay, so we can look here. Okay, message passing need to be implemented using system call by kernel. Okay, So in compared to shared memory, the system call are required only to establish shared memory region. Okay, once the shared memory region is established, all accesses are treated as a routine memory accesses. So no assistance from the kernel is required. So thus it is more um, faster compared to message passing. Okay. Okay, so that is the introduction of both of the communication models. Okay, shared memory and shared memory and message passing. Okay, we will discuss further in the next section. Okay, if we look to the next slide, so actually this slide has been discussed previously. Okay, so we can skip this slide. Okay. Alright, class, that's all for the introduction of IPC. Okay, we will discuss next on more on these two model of IPC. Thank you for watching.